So the immune response, what does our body do when we get infected with some sort of pathogen? There's two main categories of the way our body responds. We have non-specific, means it's going to respond this exact same way no matter what sort of pathogen, and in this case a bacteria, enters our body. So when you get cut, things can enter into our body, in this case bacteria. They release these chemicals called cytokines. Right? What it does is these chemicals are like magnets that draw in our white blood cells. Okay, these are called neutrophils. And they are phagocytic cells. It's a category of cells that go through phagocytosis. And they will eat the pathogens. But in science, we don't use the word eat. We use engulf, right?
Why?
And so what you see here, right, is this bacteria cell here is being engulfed through phagocytosis. So this cell is the phagocyte. And so when you get cut, what happens is all of these things, these white blood cells, leave the blood and go to the infected area. This is going to cause inflammation. If you've ever cut yourself or had acne and ever noticed that the site of infection is red, it's painful, it's swollen, and it may even itch, and it's going to be a little slightly warm too. That's the body's non-specific response to a pathogen entering in. So if you do cut yourself, and we have this bacteria that was on the tip of a needle, if you guys cut yourself, there's bacteria everywhere it's going to get in your body. And so what happens is the capillaries, right, this blood vessel, become leaky. And so fluid, well, it can't really, right, the fluid that's in them, okay, any fluid that's in here, right, and that fluid is going to be ultimately blood and, and all the things that are within it, that's going to start to leak out. Okay, and once it leaks out, it's going to start to fill in the tissue right here. And we want the fluid to leak out because guess what's inside of the fluid? These cells right here, white blood cells, those neutrophils, they're going to come and engulf the bacteria. That is what causes the swelling, right? That is what causes the pain because swelling puts pressure on nerve endings. And why is it red? Well, guess what's in blood, guys? Red blood cells. So if this infected site starts to get filled with the fluid from our blood, it's going to become very swollen and red. It is the immune system sending a bunch of troops to the area that there's fighting that needs to be had. Why do we get a fever when we're sick? We should be 98.6 degrees Fahrenheit. That's about 37 degrees Celsius. If it gets anything above that, it's regulated by the hypothalamus, which is in the brain, that senses an infection and causes our body temperature to go slightly up. We want a low fever. 100 degrees is better for us to fight the disease because it prevents viruses from reproducing, and that's what we don't want them to do. And it also prevents bacteria as well from reproducing by dropping the number of specific minerals and nutrients that they need to divide. Now, so that's non-specific. Now we're going to talk about the second one, right? This is, the first, this is the second one. Specific responses. This is how I will always be able to fight off chickenpox because my immune system is specifically designed to kill chickenpox when I received a vaccination. Right there. This is something we have to get throughout our life. We have to acquire it. We can acquire it two different ways. Naturally, right? By getting sick, right? Or by maybe receiving breast milk from our mother. Or we can acquire it unnaturally or artificially. Okay, artificially. By going to the doctor and taking things like vaccinations or ingesting serums. Now, our body has to be able to tell the difference between healthy cells and infected cells. When we get infected with something, our body can respond to become immune to it in 4 different ways. The first question you have to ask yourself, how did I get that immunity? How did I produce these antibodies to combat that disease? So, was it natural, right? Did I get sick? This is something that, or was it artificial? This is anything that revolves around medicine, okay? Or like, well, that's a little sexist, mankind, right? Let's just put it this way. Anything around just any technology, right? You took a pill, you took some serum, you got a shot, right? This is intervention of mankind or womankind. The second question is, did you produce the antibodies yourself? You're going to have a quiz and you're going to have to answer, is it naturally active? Okay, that's one. Or naturally passive. Is it artificially active or artificially passive? Let's go through some examples. Naturally active. This is just flat out getting sick. You have to get an infection. Oops. Right? When you get an infection, your body cells recognize the pathogen and it starts to produce its own antibodies. If you got sick by the flu this year, you're probably not going to get sick again. Passive. Okay? I didn't produce the antibodies if I was an infant when I took in my mother's milk. Inside of the milk are antibodies. The female, right? The mother's the one that got exposed to antigens throughout her life. She produced antibodies and now is giving it for her child to borrow. When you do something passive, you're borrowing somebody else's active antibodies. Both of this is natural. Okay, so how do you artificially become actively immune to something? These is when we're talking about vaccines. But you still produced your own antibodies. This is when I inject smallpox vaccination, polio vaccination, flu shot. I put in a weakened form of the virus. That's what a vaccine is. My body learns about that virus and then generates antibodies. Antibodies are these little Y-shaped proteins that go and attack and bond to pathogens. Lastly, passive. So, if I take what's called a serum, which is a solution that has antibodies in it, and then drink or inject that and get that in my body. If you've ever been bitten by a snake, you can take this. Has anybody ever heard of this? Antivenom. How do they make antivenom? Well, what they do with antivenom is they take venom and they put it into... They would take venom from they milk a snake's fangs and they put it into some sort of animal, like a cow or a sheep. The animal gets sick, right? From the immune system reacts and starts to produce antibodies that are specifically targeting against that venom. So then we remove those antibodies from the animal and we make some sort of serum solution. And this is the serum, is what we call the antivenom. If I get bit by a snake, I can now inject this into my body and it already has antibodies in it. Not my own, somebody else's. I keep using this word antigen. An antigen is something on the surface of a cell that is recognized by the immune system. It's typically a protein. And so our immune system has its own proteins that match up and can recognize it. It's very much a lock and a key. Right, here's an antigen on the surface of a cell right here, right? This little triangle. My antibody has to fit that antigen. If I have something that doesn't fit, okay, it's not going to recognize it. The body only responds to things, okay, that it fits and matches perfectly to. There's two types of ways we can respond. Number one, cell-mediated. When our body bumps up against to these antigens on infected cells and then triggers T cells to make killer T cells. It's a cell that does the killing. That's why it's called cell-mediated immunity. And that's primarily associated with T cells bonding to antigens and killing them. There's also something called humoral immunity. Humoral immunity has to do with B cells. B cells, also known as plasma cells. Well, these B cells turn into plasma cells, and they produce antibodies. So we can either have cells attacking and killing. This is a cell itself. Or we can have the products of cells, which in this case are antibodies, doing all the killing. And in antibodies, they're produced by B cells, which are in the lymphatic system known as lymphocytes. An antibody is shaped like this, like a Y. That's actually shaped like this. It's got this part, and it has a very specific end to it that's shaped, and it will bond only to specific antigens. What antibodies do is when they bond to cells, they trigger these giant phagocytes to go over there and then kill. So these guys are like little markers that help gather and tag bacteria or infected cells for destruction. One of the reasons why we can reject a tissue, right, if it's not a match, right? We talk about the heart organ being a match. So, I've been on the tissue organ list forever. I'm just waiting for a match. If I take in a heart, if I get a heart transplant, and on the surface of the heart cells of the new heart that I got are antigens that my body doesn't recognize because I don't have them myself, then my white blood cells will attack and destroy that organ because it thinks it's a foreign invader. So you want to get organs that have the same things on the surface, right, as you do. So if this is your brother or sister, he or she's got the same antigens that you do, your immune system will not reject that organ. It will not attack.